Hi, this is Pat Kelly.
Okay, in this problem, it's a little bit of hands-on, but a lot more brain-on. We have to do some thinking, so I really like this type of problem. It says to use a graphing utility, so go ahead and grab one of those, make sure it's handy. And what we're supposed to do is in the same viewing window, graph the f of x that they gave us, the g of x that they gave us, and then they ask us also to find the f plus g and put it in that graphing utility. And I've got a head start on you. What I did is I graphed the f of x and the g of x. I saved f plus g because it's actually part of the hands-on that we need to do. Is of course you need to know how to find the expression for f plus g given f and g, which you've done a few of these, I'm sure. You just add them together. So for me, I'm looking at 3x minus, because that's a negative, x cubed over 10. And so that's my f plus g function that I also want to put in my graphing utility. So if you're fast, you've caught up to me, but I'll grab my graphing utility because I do still need to plot that function. So let me get into my y equals, and I'm putting in the 3x, subtract the x cubed divided by 10, in addition to the 2 that I already have in here. And if you graph this one, my utility is getting those first 2, and the third one, the new guy here, looks something like this. Let's see how well I can draw this. Yours, I hope, looks similar. You're probably drawing yours better, though. Like that. Okay. And that's it in terms of the hands-on. But I got excited. I like this problem because there's a little bit more brains-on work to do. We have to do some thinking. Because the second half of this question asks, which contributes more? Which of the original functions, f or g, contributes more to the magnitude of f plus g? Now I omitted the word magnitude here on the board, but all that means is I don't care whether we're talking about really high positive values or really low negative values. In either case, positives or negatives, which of the original functions, f or g, is contributing more to f plus g? And first they ask us that when x is trapped between 0 and 2. So what we're going to do to answer that is to go over to the graph and look. We'll observe between 0 and 2 on the x-axis, that's here. The new graph that I just drew, the third one, it's green for me, that's here. And between 0 and 2, it's really behaving a lot more like the pink. It's tending toward where the pink graph is, the f of x. Whereas the yellow graph, the g of x, that's flat here. That's actually down towards 0. And the green graph is definitely high up here, similar to the pink graph, the f of x. So my answer is which function, f or g, contributes more to the magnitude of f plus g? Just between 0 and 2, I'm going to say f of x. Okay. Pause, take a breath. Same type of thinking, but this time we're looking at x greater than 6. So when we're way over here, 6 or higher, which of the functions f or g is contributing more to the green graph? Well, from 6 on, my gosh, my pink graph is off the charts. It went way up very quickly. But my green graph is going down, down, down. In fact, mimicking the behavior of the yellow graph. That's telling me the green graph is being very strongly influenced by the yellow graph, which was g of x. So my answer, which contributes more when x is greater than 6? The g of x graph. Okay. And this is a great problem to think about what's going on, because what I hope you're seeing is that especially with this pink graph, it spiked so quickly, it went way, 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 way up. That's a linear graph. What we're seeing is with low values of x, when we're still between 0 and 2, linear expressions really have a lot of influence. They sway what's going on a lot, more so than a power, like x to the 3 power. However, when x's start getting bigger, even though that pink graph is way up high, the power, the x cubed, is dominating. So an x to the 3 power has more say than a linear factor. And that's why g of x was the answer there in the second part. Okay? Hope that gives you something to think about. Use the same type of thought process in the other problems that you'll do on your own. Go do some.